All right, welcome to the Explainer. Today, we're doing a masterclass on HARQ. Now, this is a critical piece of 4G tech that's working literally every single second your phone is connected, just to keep you online. So let's just dive right in with a simple question that really gets to the heart of why IARQ is so important. Ever wonder why your 4G connection doesn't constantly drop, even when the signal is super weak? Or how you can stream video in a moving car without it buffering all the time? Well, the answer is this system, and it's incredibly fast, and you'll see, surprisingly clever about how it deals with failure. Okay, so to really get why HARQ is such a game changer, we first have to look at what came before it. See, older systems, they had a simple but honestly a really wasteful way of dealing with errors. And that just wasn't going to cut it for the fast-changing, kind of hostile radio environment of a mobile network. And here it is. This is the fundamental difference right here. A standard automatic repeat request, we'll just call it ARQ, it would just get a corrupted data packet and throw it in the trash, ask for a complete do-over. But HARQ, its strategy is brilliant. It sees that corrupted packet not as garbage, but as valuable information that just needs a little bit of help. So what does it do? It saves it. And this visual? It just illustrates the core concept perfectly. Your phone stores that garbled data in a special little holding area, a soft buffer. Then, when the retransmission shows up, it combines the energy from that old bad attempt with the new one. And this process, it's called soft combining, and it's often all it takes to create one perfect error-free packet. It's literally recycling failure into success. How cool is that? So that's why we call it a hybrid. See, HARQ combines that simple re-request idea from the old ARQ with some really powerful math called forward error correction, or FEC. And then it fuses them both together with that soft combining trick, right down at the hardware level. It's this unique mix that makes it just so incredibly fast and efficient. Okay, so that's the what, but how does this elegant system actually work in practice? Well, it's all built around one single fundamental timing rule. You can almost think of it as a physical law of the network that dictates, well, everything. 8 milliseconds. I want you to burn this number into your brain. It is the unbreakable heartbeat of LTE HARQ, and it dictates the entire architecture we're about to break down. Now, this 8 millisecond round-trip time, it's not just some random number they picked out of a hat. No, it's the actual physical time it takes for a signal to travel from the tower to you, for your phone's hardware to process the data, and then send back a tiny little message. It's either an ACK, which just means, yep, I got it, all good, or a NACK, which means, nope, send it again. But wait, this fixed timing creates a brand new problem, right? Think about it. If the network sends a packet and then it has to just stop and wait a full 8 milliseconds for feedback, how could you ever get high data rates? I mean, that would be like trying to have a conversation where you can only say one word every 8 seconds. It just wouldn't work. And this lie really hammers home just how insanely wasteful that would be. For every one single millisecond of data you send, the network would spend the next 7 milliseconds just sitting there, idle, waiting. You'd be using less than 13% of the total capacity. Your throughput would just completely fall off a cliff. So what's the solution? Oh, it is incredibly elegant. Instead of having just one slow conversation, the network basically holds 8 conversations at the exact same time. It runs 8 totally independent HARQ processes in parallel. So it sends a packet for process 0, then boom, a millisecond later it sends one for process 1, and so on. By the time it gets all the way to process 7, it's just about to get the feedback for that first one, process 0. The whole cycle just continues perfectly, and that ensures the data pipe is always 100% full. Genius. All right, so now we get the architecture. Let's dig into a key detail that really separates the pros from the novices. And by the way, this is a favorite question in technical interviews. HARQ actually has 2 very different personalities depending on which way the data is flowing, whether it's coming down to your phone or going up from it. Okay, so here is the crucial difference, laid out plain and simple. Downlink HARQ, that's from the tower down to your phone, is asynchronous. The network is the boss, right? It can retransmit whenever it thinks is best, but it has to tell the phone which of the 8 processes that data belongs to. But the uplink from your phone up to the tower, that's synchronous. It's rigid. A retransmission must happen exactly 8 milliseconds later. And why? Well, it saves your phone's battery big time, because the timing itself tells the tower the process ID. No extra signaling needed. So clever. And this side-by-side really makes it crystal clear. Look on the left. The downlink has all this flexibility. The network scheduler can decide when it's ready to send that retransmission. But on the right, the uplink is just strict clockwork timing. If your phone sends data and gets a NACK back, it knows without a doubt, I must retransmit this thing precisely 8 milliseconds later. No questions asked. You know, you can really think of HARQ as the system's rapid response team. It's incredibly effective, handling something like over 99% of all radio errors. But it's not invincible. So what happens when it's tried a few times and it still fails? This visual is just a brilliant way to picture the whole system. HARQ is that fast frontline soldier. It's operating way down at the lowest layers, taking on the messy, high-speed battle against all those radio errors. But when that soldier gets overwhelmed, well, the problem gets escalated up the chain of command to a higher layer called RLC. Now, RLC is a lot slower, we're talking 50 milliseconds or more, but it's the final safety net. It's what guarantees 100% that your data will get through. And these are the real-world situations where that exact failure escalation happens. Maybe you're at the very edge of a cell, and the signal is just so bad that even a bunch of HARQ retries aren't enough. Or maybe a low-end phone simply runs out of buffer memory. In these cases, HARQ basically throws its hands up and says, I'm done, and lets the slower but much more robust RLC layer come in and clean up the mess. All right, let's bring it all home. If you're going to remember just one thing from all this, make it this sentence right here. HARQ is the fast intelligence system that reuses bad data instead of just trashing it. It all works on that strict 8-millisecond heartbeat, running multiple conversations at once to keep your connection totally saturated and super reliable. So really, the key takeaway here isn't just about how HARQ works all by itself, but how it fits into this beautifully engineered system of reliability. And that leaves us with one last kind of deeper question to chew on. If HARQ is the fast frontline soldier and RLC is the slow, guaranteed safety net, how in the world do their timers coordinate so perfectly that they never, ever trip over each other? Unraveling that? Well, that's a masterclass all by itself.